Hello everyone, welcome to this webinar, Men&Mice webinar, DNS Wildcards Demystified. With me today is Karsten Strootman. Karsten, can you maybe introduce yourself?
Thank you, Peter. Yes, hello, here's Karsten from Men&Mice. I'm in the Men&Mice service team, and I would like to give you today a little bit of information about DNS wildcards and how to use them and how not to use them.
Before we start, Karsten, first of all, I wanted to present myself as well. My name is Peter Petersson. I am from the sales team at Men&Mice. Men&Mice is not only providing webinars, but we are also providing solutions for DNS and IP address management and DNS trainings around the world. And we are happy providing you with this and other webinars as well. This webinar is recorded, so if you have to jump off this webinar earlier than expected, you will have access to this content online afterwards as well. And you can also find other webinars and all other taped or recordings online as well. But without further ado, Karsten, thank you for joining us today. So the audience is yours.
Thank you, Peter.
And maybe, one more thing. During the webinar, don't hesitate posting some. You can post questions through the chatting part of the control panel. Very good.
So, hello and good morning again. So, DNS wildcards. I start this time with the demo first, not demo at the end. So what are DNS wildcards? I'm bringing in here a terminal window. I will show you some DNS wildcards in action. So I've set up a DNS wildcard, and DNS wildcard is actually a specific DNS record that looks like this. Oops. Let me use a different keyboard. So this is an example of a DNS wildcard. So it is a DNS name containing an asterisk or star at the very left side of the DNS name. And whenever we have such a DNS record in a zone file, this will matching any queries that can be found, can be asked to the DNS server. That on the left-hand side of the domain name has any number of labels, and on the right-hand side ends in example.com and is the question for an A record. So to give you an example, I have a wildcard at wildcard.dnsworkshop.org. So if I'm asking for www.wildcard.dnsworkshop.org, A record, I'm getting back the IP address 192.0.2.88. If I ask a different name like webinar, I get back the very same address record. So no matter what domain name I'm sending, even if that domain name has multiple dots in there, so like webinar.wednesday.in.april.wildcard, also that very long name that we see here will result in the very same IP address. This is how wildcards work. That is what the user sees of the wildcard. And we will now have a look behind the scenes, look how wildcards are really working on an authoritative name server. So an authoritative name server, when there is a wildcard in a DNS zone, it will synthesize So it will automatically create the DNS answers from these wildcard records. The rule is that a wildcard is a domain name where the leftmost label is a single asterisk. And there are no other wildcard characters in DNS other than the asterisk. So even though the DNS wildcards look similar to wildcards that you see in other systems, like the Unix shell file name globbing, or the star.star that you can use in DOS or Windows file names, or maybe even regular expressions, DNS is a little bit different, even though it looks very, very similar. So there is no like question mark DNS wildcard in DNS where you can substitute just a single character. You can only use that one asterisk as a wildcard, and only in the leftmost character. The specification for wildcards is as old as DNS itself. It was defined in the original DNS RFC of 1034 back in 1983, and it has been updated lately with RFC 4592. And RFC 4592, the role of wildcards in the domain name system is a must-read for everyone who wants to understand the subtle nuances of the DNS wildcards. And this presentation, this webinar here, is a condensed version of what's in that RFC. So here we have more examples of DNS wildcards from different zones. So these records that we see here at the top are not all in the same zone, wouldn't work. They are in different zones. So in the first line we have star.example.com, an A record, star.firma.example.com is an MX record, and star.example txt wildcard, and even says a wildcard in the txt record. On the lower part of the slides, we see records that are not wildcard records. The first one, startest.example.de, is not a wildcard because a wildcard is only there if there's a single asterisk in a label. So there cannot be any other text between the asterisk and the dot that separates the labels. Also, the second line, test.*example.com, is not a wildcard because the asterisk can only appear in the leftmost label. If it appears in the middle of a domain name, it's just that an asterisk. So it is just a funny looking domain name, and it will be looked up as is. So only a request for test.star.example.com will resolve that txt record. And the last one, with star.example.com, is also not a wildcard because only a single asterisk makes a wildcard. In the next slides, I will present you some requests to a DNS zone on an authoritative server, and we will together look in what kind of answer the authoritative server will respond. So here we have an example zone file that is hosted on that authoritative server. It has a start of sortie record, it has its NS record, it has then two wildcards, one text record, one MX record. Oops, sorry. So the first one is this one here, star.example txt record. This is a wildcard. And the second one is below, it's the MX record for 10host1.example. Then we have a subdomain here, sub.star.example, which looks like a subdomain of a wildcard, but it isn't. It's just a normal DNS name. And we have some SRV records in here. We have an A record, and we have a delegation down to a real subdomain that is a delegated subdomain called subdel.example. So we will use this zone, and I will present requests that are being received by the authoritative server. And I will, when we see the request, I will make a small pause in the presentation so you can really think of what answer will be sent back by the authoritative name server. And let's see if you are right or wrong, because there's subtle nuances in how the wildcards work. So here on this slide, we see the same zone on the left-hand side, and we see the tree, the DNS tree on the right-hand side that makes this zone. So we have on the top the root zone, a delegation there to example, and inside example we have this tree. We have star.sub on the left-hand side, that is the txt record called, this is not a wildcard. We have the SRV records, host 1, host 2, and we have subdel, and everything else is at the example node. So now what happens if this authoritative server hosting this zone receives a query for host 3 example? Record type MX record. Will this be a wildcard expansion or will it not be a wildcard expansion? Think about that a second and then I show the result. It actually is a wildcard response here because that one MX record over here that matches the request. So host 3, there is no other label, there's no other resource record starting with host 3.example. So because of that, this wildcard is being used. The rule is that whenever a request is being received by an authoritative server, that authoritative server will look for what's called the closest enclosure, which is a construct that I will explain a little bit later. But basically it is looking for the same name as in the request. And if there is not the exact same name, so if there is no host3.example, then it looks for a wildcard record that matches. And in this case, star.example does match. And we have an MX record for this. Next request is for host3 example A record. Think about it. Will there be an answer for this request? Or better, will there be a positive answer? No. This time we get a negative answer back. A negative answer in DNS, this is called no error, no data. So in the header we see no error return code, but there's no answer in there, meaning the name exists, but the record type doesn't exist. So the name actually exists because of the wildcard expansion. Host3.example would match because we have seen it already matches the MX record if asked for, but for the star.example, there is no A record. We have a txt record type for star.example for the wildcard, and we have an MX record type below that, but there is no A record, no address record. So this answer is a negative answer. So next is a request for a txt record of foo.bar.example. Now, does that match? Will we get an answer back? Yes, we get an answer back. foo.bar.example matches the very first wildcard, the txt record wildcard for star.example. So it doesn't matter how much labels are appended or prepended on the left-hand side. The record type matches, it's a txt record, and it ends in example, so it matches this asterisk.example wildcard record. So the next one is host1.example MX record. Look into the zone and see if it matches. So like, does it match this MX record here? The first star.example MX record. Now it becomes tricky. No, it doesn't. The answer is a no error, no data. Why? Because there is a host1 example record. It's an A record. And because there is already a record in the zone with that name, the MX record will not expand to a wildcard, or will not be expanded by the wildcard record, even though it would otherwise match. The existing name that is in the zone takes precedence. So here we ask for sub.star.example, MX record. Will we get an answer back? Will it be a positive or a negative answer? So we have a sub.star.example, but it's a TXT record. Will this override the star.example MX record? It actually will. So the answer here, again, is a no error, no data, because there exists a TXT record for sub.star.example, so there is no wildcard expansion here. The next query we see is for _telnet._tcp.host1.example SRV record. So will we get an answer back here, and will it be a positive or a negative answer? Again, no wildcard expansion, because the closest enclosure would be TCP host1 example SRV record. It's an SSH entry that we see here. So because that name exists and it is closer than just star.example, this is being used to look up the name, and the exact name _telnet TCP doesn't exist. What about if we ask for host1.example A record? Do we get an answer back? And which answer we get back? In this case, it's just a normal DNS lookup. So host1.example exists as an A record, and this is the data we get back. If we ask for host subdel.example A record. Now subdel.example is a delegation down here. So we have NS records pointing to different name servers, nsexample.com and nsexample.net. Will wildcard expansion happen here? No, it does not. Delegation always has higher priority than wildcard expansion. So an authoritative name server will first look in the zone file, see if there is delegation, if this is a request that needs to be handled somewhere else. And in this case, it needs to be handled by the authoritative name servers for that domain, subdel.example, which are nsexample.com and nsexample.net. So the answer from this zone would be a referral, telling the caching server, please go to these other name servers and ask them. Now, if we query for ghost.star.example MX record, would that match any of the wildcards, the star.example wildcards? There is a star.example MX record in the zone. Interestingly, no, it doesn't match, because the star doesn't match its own wildcard, meaning that the star.example doesn't match a star. It matches everything else. So if we would ask for ghost.plus.example, that would match, but not ghost.star.example. That retrieves, or that returns a no error, no data. What about if we really ask for just star.example TXT record? What will be the answer? We're asking directly for this name. If we ask directly for this name, then the asterisk has no special meaning. then the wildcard is not a wildcard, it's just a normal resource record, and it's been returned as is. So we really get back an answer for star.example and the TXT record. So this was the different variations of wildcards that we can see. Now, in order to understand how wildcard expansions works and how wildcards are found in a zone file, we have to understand the concept of an empty non-terminal. An empty non-terminal in DNS is a label in the DNS tree that itself doesn't hold any data. And we have three empty non-terminals in this zone. The first one is the star.example. And that is kind of a special case. So first I cover the other two, which are the underscore TCP host1 example and TCP host2.example. So host1.example is not an empty non-terminal just on itself because it has an A record. But underscore TCP.host1.example has no other data. So it is part of a name, but there is no resource record here that is just named underscore TCP.host1.example. The same holds true for underscore TCP host2.example. And because of the special meaning of the wildcard, the sub.star.example is also an empty non-terminal, meaning there is no data on itself hosted at star.example. So here we have the tree again, and we see our three empty non-terminal nodes in the tree. So all the other nodes, they contain data. Host1 example contains an A record. Subdel contains the NS records. Example itself contains the SOA record and NS records and so on. So when looking for DNS wildcard expansions, the authoritative name server looks into the zone and finds the closest enclosure. The closest enclosure is the resource record in the zone where the name on the right-hand side matches the most. So the longest match inside the domain name. So if then there, for this closest enclosure, if there's no explicit resource record, then the authoritative server looks for a wildcard record on that closest enclosure. So it looks like for a record that starts with an asterisk and then dot, and that has the closest enclosure to the name being requested. And if that exists, that name will be used for wildcard expansion. We have some examples here on this slide, also taken from the example zone. So the first domain naming query is host3.example, and the closest enclosure in the zone, because there is no host3.example name, would be example. And then we look for if there is a wildcard record directly descending from the closest enclosure, which is star.example. So this one is a wildcard answer. That star.example is being used as a source of the record synthesis. For underscore telnet underscore TCP host1 example, the closest enclosure would be underscore TCP host1.example, which contains an SRV record but doesn't contain any wildcards. So we have no source here. The answer would be NX domain in this case. And the same holds true for the second one, for underscore DNS underscore UDP host2.example. The closest enclosure is host2.example in the zone, and we have no source. It's different with host3. If we use underscore telnet underscore TCP host3.example, the closest enclosure we find in the zone is example, and there we have a wildcard, star.example. And the same is true for _chat_UDP. So no matter what different labels we have on the left-hand side, they all match. For foobar.star.example, the closest thing closer already is star.example. So the rule says that we look at a wildcard record that is in front of this. So we would look for an asterisk.example, which doesn't exist in this zone. So we have no source of a wildcard record here. So foobar.star.example also results in a negative NX domain. A few other rules about wildcards and DNS. Now, in normal DNS, meaning DNS without DNSSEC, it is kind of legal, although not recommended, but it is legal to have wildcard records in NS records. That is sometimes done by large ISPs that have a lot of DNS hosting, and they just delegate everything from a specific name down to a set of the same name servers. So like here, star.example.com, so every domain that ends in example.com is being authoritatively hosted on ns1example.org and ns2example.org. That works in normal DNS, but it breaks with DNSSEC, because in DNSSEC there's then no way to really verify the signatures for these NS records. So don't do this in a DNSSEC signed zone. Also, a common mistake with wildcard records is treating the SRV and also other records that have a selector on the left-hand side. Selector meaning something like _LDAP or underscore port number for TLSA records. These are really parts of the domain name. They are special parts of the domain name, but technically they are parts of the domain name. So something like _LDAP_TCP.star.example.com is not a wildcard. It is just a funny looking normal DNS record and will only be returned if a client really asks for exactly that name, which is very unlikely. So we cannot have wildcard expansion on SRV records. And the same holds true for domain key identified mails, DKIM, or TLSA, or other resource records that make use of selectors. A few more rules, but they are mostly esoteric. If there are wildcard delegation signer records in a parent zone, that is also for DNSSEC, they are just ignored because they cannot exist. DNAME records. DNAME is a special case of a CNAME record, where a CNAME record just aliases a single resource record, or all resource records on a single name. A DNAME can be used to mirror and alias a whole zone. DNAMEs have their own special problems and are not widely used. And wildcard DNAME records are not allowed at all because they would break the DNS. And the rule, and we have seen that already, if the source of the synthesis is an empty non-terminal, so there's no data really stored on the source of the synthesis, the answer will be a no error, no data. Meaning the name exists, which is true, but there is no data stored at this code point, at this node in the DNS tree. So, too long to read, or too long don't read. The last word for this is just be careful with DNS wildcard records. They can be useful, but really understand the rules that lead to wildcards and test it before you deploy wildcard records. So let's see, Peter, do we have any questions?
Yes, and while we're waiting for more questions, you guys can type in questions in the question part of the control panel. Maybe first a question from me, Carsten. Looking back, are these wildcard records a good idea overall? Should we have designed the DNS without them?
I would say it would certainly possible to run DNS without them. There are some cases where wildcard records make sense, but they should be really restricted. So I would recommend not to use them unless you really understand what you're doing there and unless there's no better way to achieve the goal. So I see a question here from Peter, another Peter. The question is sub.star.example.a a legal, or I think the A is part of the request. So is sub.asterisk.example a legal resource record? It is, first of all, a legal domain name. And yes, if there's a record type and data after it, it would be a legal resource record. And it can be requested as is. It is legal in a zone file, and you can just put it in a zone file. And if you send then a request for that, you get an answer back. I can demo that here in this. If I just ask for star.wildcard.dnsworkshop.org, a record. And now my shell, I need to escape this name so that it is not seen by the Unix shell. So we then get just the answer, the resource record back, just as it would be a normal resource record. So we see here star.wildcard, and we see it's an A record. And the same would be true for sub.star.example. That is not a wildcard then, if we use a label in front of the star, but it would be just a legal resource record that we can request. Do we have more questions?
Yeah, Carsten, there is a question here from Laurus. Can wildcards be used to cancel zone walking in DNSSEC?
No, they cannot. Good question. They cannot, because the wildcard is also part of the NSEC chain. So let's see if I can generate an example here. Or yeah, I can just try, because this zone, as we see, has a wildcard. And if I do ldns walk on dnsworkshop.org, we see here it's a small zone. It's been walked, and we see there is the name dnsworkshop.org, which has a record, a SOA record, quad A record, and NSEC and DNS key, and this type 65534, which is a bind internal one. Then we have a TLSA record, which is type 52, and then we see the wildcard here, and it's just listed as a normal record in the zone walk, and we see there's a website www.dnsworkshop.org. So no, unfortunately not. Wildcards doesn't stop zone walking. It just works with zone walking as well, and all the records, including the wildcard, will be printed out.
Okay, and then I have a question from Dave. Can wildcards be used with CNAMEs?
Yes, they can be used with CNAMEs, just as in any normal resource record. So on the left-hand side of the resource record of the scene, they don't work on the right-hand side. On the right-hand side, it would just be a funny-looking domain name with a star in there. But on the left side, you can write something like star, domain name, CNAME pointing to another name, and then all the resource record that exist on the destination of the CNAME will also exist for the wildcard record. That just works. It is also possible to point a CNAME record on the right-hand side to a name which by itself doesn't exist, but would be synthesized by a wildcard. That also works. Because mainly the CNAME expansion, that happens really on the caching server. So the caching server gets back the CNAME, and getting back a CNAME means for a caching server, you have asked for the wrong name. Please ask again, but this time for the new name, the name that is on the right-hand side of the CNAME, and then the caching server will do that, and normal DNS name resolution rules will apply there.
Very good. Thank you, Carsten. The final question I have here in the control panel, at least for now, again from Dave. It's how are DNS wildcards cached?
The wildcards itself are actually not cached, but the results of wildcard expansion is cached. So the wildcard expansion happens on the authoritative server. Whatever the caching servers and also the client machines never see the wildcard itself. What they see is the result of wildcard expansion. So there should never be something like star.example.com being in some caches, and it will definitely not expand it if it is there. It's only expanded on the authoritative server. So the answer coming back, like in our case here, if I ask for wildcard.dnsworkshop.org, this is the result of wildcard expansion, and the time to live is 60 seconds. And this record, which is in the answer, which is the expanded wildcard, that will be stored in the cache or will be stored at the client machine.
Thank you. I see no further questions, Carsten. So I think we'll put an end to this session by now. Now, all of this has been recorded, and we will put the session on our website and send a notification for download of the information to you guys as well. So, Carsten, thanks for joining us today. And all of you, we hope to see you soon at our future webinars. So, keep an eye on our emails. Thanks. And have a nice day.
Thank you for listening. Bye for now. Have a great day.